welcome to the deep dive. Today we're tackling something really crucial for, well, keeping your digital life secure. We're using this great set of sources you shared.
Yeah, looking forward to it. We're going to explore how tech is, evolving to safeguard digital assets.
Exactly. And specifically, we're diving into multi-party computation MPC and how it's being used for crypto wallet security.
Right. We've got insights from Web3 Auth, Lit Protocol, Wikipedia, Fireblocks, and a really useful beginner's guide to MPC wallets. It gives us a pretty broad picture.
Okay, let's get into it. Our mission today isn't just to define MPC. We really want to understand why it's so important now for protecting digital stuff, look at the different ways people are actually doing it, and maybe peek at where it's headed.
And the goal is to pull out the key ideas, those aha moments from these sources without getting bogged down in, super technical stuff.
Perfect. So first things first, what exactly is MPC? Layman's terms, if possible.
Okay, so at its core, MPC is a type of cryptography. It lets multiple people or parties work together on a calculation using their own private data. But here's the kicker. They do it without revealing that private data to each other.
Okay. So collaborative computing, but keeping your own input secret.
Precisely. It actually goes back quite a way to the 1980s. The really revolutionary part isn't just splitting data up. It's the mathematical proof that unless you have enough pieces, enough participants, you simply cannot reconstruct the original data. Even with massive computing power, it's a different way of thinking about trust.
So it's not just hiding. It's mathematically impossible to figure out the individual pieces from the outside, or even if you have some of the pieces.
Exactly. Think of our friends John, Rob, and Sam. They want to figure out who earns the most, but nobody wants to say their salary out loud.
Right.
MPC provides a way for them to calculate the highest salary among them without anyone ever having to reveal their actual income to the others.
Okay, that analogy really helps. So what are the underlying principles that make this possible? What's the magic?
Well, it's not magic, it's math. But there are two key concepts. First is secret sharing.
Secret sharing. Okay.
This means taking a secret, like a private key for a crypto wallet, and splitting it into several different parts, or shares. These shares are then given out to different participants or stored on different devices.
And the key is you need multiple shares to do anything.
Exactly. The original secret can only be put back together if you have a specific minimum number of shares. That minimum number is called the threshold.
Gotcha. So it spreads out the risk. No single share gives you the whole secret. And the sources mention different flavors of this, right?
Yes, a couple of main ones. There's Shamir's secret sharing. It's from '79, very widely used. It's based on polynomial interpolation.
Okay, math class flashback.
Yeah. Basically, the secret is encoded as a point on a mathematical curve, a polynomial. Each share is just another point on that same curve. You need a minimum number of these points, the shares, to figure out the exact shape of the original curve, and therefore find the secret point. The beginner's guide called it like a jigsaw puzzle.
Right, you need enough pieces to see the picture.
Exactly. And crucially, even if you have almost enough pieces, you still don't know the final picture. You absolutely need that threshold number.
Okay, that makes sense. And the other one?
The other main approach is Blakely's secret sharing from around the same time. This one uses geometry. Imagine the secret is a specific point in, say, 3D space.
Okay.
Each share is like a flat plane, a hyperplane in that space. The secret point is where enough of these planes intersect.
Like finding a location where several lines cross on a map.
That's a great analogy, like a treasure map, yeah. Each share gives you a constraint, a boundary, and the treasure is only revealed where enough boundaries meet.
Interesting. Two different paths to the same goal. You said there was a second core principle?
Yes. The second big idea is computational trust.
Computational trust.
Yeah. Think about traditional security. Often trust is subjective, right? You trust a person or a bank or a brand.
Sure.
In the digital world, especially with things like blockchain and MPC, trust is shifting. It's less about trusting who someone is and more about trusting the math, the algorithms, the protocols themselves.
So the trust is in the code, in the cryptography, because it's provably secure based on mathematics.
Precisely. Your sources mention this in the context of blockchain, the cryptography securing transactions, the consensus rules keeping everyone honest. MPC is another example of this. You trust the process because the math guarantees certain outcomes, distributing trust instead of concentrating it.
Okay, that's a fundamental shift. So we have Secret sharing to break up the key,
Hmm?
and computational trust based on math. How does this all come together in these MPC wallets? What makes them different?
Well, an MPC wallet basically builds on those principles to make digital asset storage way more secure. The big difference from, say, a standard software wallet or even some hardware wallets is that there is no single, complete private key stored anywhere.
No single key file to steal.
Exactly. Instead, that private key is mathematically split into those encrypted shares we talked about.
And these shares could be anywhere, like one on my phone, one on my laptop.
Yeah, or one with a service provider, one on a dedicated hardware device. Different setups are possible. And here's the crucial part. When you want to make a transaction, say, send some crypto, those shares don't get sent to one place to be reassembled into the full key. That would recreate the single point of failure.
Ah, okay. So what happens instead?
Instead, the devices or parties holding the shares use MPC protocols. They kind of talk to each other cryptographically and collaboratively sign the transaction using their shares, but without ever putting the full key back together.
Wow, okay. So the key itself, in its complete form, never exists in one place during the signing process.
Correct. It remains fragmented throughout. That's the core security enhancement.
That does sound much safer than having that one critical file or phrase.
Huh.
The beginner's guide had some analogies for this.
Yeah, it did. One was like a company needing multiple managers to sign off on a big payment. No single manager can just transfer the funds alone.
Right. Distributed authority.
Or like a group of friends sharing a crypto investment pool. They might set it up so that, at least 2 out of the 3 need to approve any withdrawal. MPC enables that kind of multi-party control natively.
Okay, so if I'm using an MPC wallet and I want to send some Bitcoin, what's the simplified flow? What happens?
Okay, simplified version. You initiate the transaction in your wallet app. Your device, holding its share, starts talking to the other places, holding the other shares, maybe another device, maybe a secure server. Using MPC, they all perform calculations based on their own secret share and the transaction details. They exchange messages, but never the shares themselves.
Got it. Secure computation happens in a distributed way.
Exactly. They collectively generate the cryptographic signature needed to authorize the transaction on the blockchain.
Without the full key ever being assembled.
Right. The final result, the valid signature, emerges from this collaboration, allowing the transaction to go through. The key itself stayed split up the whole time.
That's clever. Okay, so putting myself in the user's shoes,
Yeah.
why should I care? What are the real tangible benefits here?
The biggest one, hands down, is enhanced security. You're basically eliminating that single point of failure.
Because there's no single key to target.
Right. If a hacker gets one share, maybe from malware on your phone, they still don't have the whole key. They can't drain your wallet. It dramatically reduces the risk of theft or unauthorized access. This is huge, especially compared to just storing a private key directly on a device.
Yeah, that's a massive advantage. What else?
Resilience. Because the key is distributed, if one device holding a share is lost, damaged, or compromised, the wallet isn't necessarily lost. You can often recover access through the other shares or recovery mechanisms.
Okay, less risk of catastrophic loss.
Definitely. Then there's flexible multi-signature functionality. MPC makes it easier to set up wallets that require multiple approvals for transactions. Great for businesses, DAOs, or even family sharing assets.
So I could require both my phone and a hardware key to approve a large transfer, for instance.
Exactly that kind of thing. Plus, they generally offer cross-platform compatibility. The MPC logic can work across different devices, phones, computers, hardware tokens, and you get adaptable authentication. You can layer other security measures like biometrics, 2FA, or hardware keys on top of the core MPC security.
So it's not just MPC, but MPC plus other factors.
Often, yes. It fits into a layered security approach. Also, importantly, you can find both custodial and non-custodial options.
Ah, so I can choose if I want full control or if I prefer a service to help manage things.
Right. It offers flexibility depending on your comfort level and needs. And related to resilience is simplified recovery. Losing a single share doesn't have to mean losing everything. There are often secure ways to regenerate a lost share without compromising the whole wallet.
That's a big relief compared to losing your seed phrase for a traditional non-custodial wallet.
It certainly can be. And finally, they offer scalability. MPC can handle complex approval workflows, making it suitable for enterprise use cases too.
Okay, that's a compelling list of pros. But, there's always a catch, right? What are the downsides or challenges? the things to watch out for.
Absolutely, there are trade-offs. One major consideration is increased complexity, especially for less technical users.
Yeah, I can see that. Managing multiple shares, understanding the setup, it might feel more complicated than just having one key or seed phrase.
It can be. There's also a dependence on multiple devices or parties. If one part of your setup fails, maybe your second device breaks or a co-signing service is down, it could potentially delay or block your access to funds. Logistically tricky in emergencies?
Okay, so the distribution can be a strength, but also a potential bottleneck.
Potentially. There can also be higher costs involved. The infrastructure for running robust MPC systems, especially for service providers, can be more expensive, and that might translate into higher fees for users sometimes.
Makes sense. What else?
While recovery is generally better, there can still be recovery challenges in extreme scenarios. What if you lose multiple shares simultaneously? Recovery might still be complex, or in worst cases, impossible, depending on the setup and threshold.
Right, it reduces risk, but doesn't eliminate it entirely if multiple things go wrong.
Correct. Also, it's still a relatively newer technology in the grand scheme of wallets. So industry support and adoption isn't universal yet. Not every platform or dApp might integrate smoothly with every type of MPC wallet.
Okay, compatibility could be an issue sometimes.
Possibly. For very active traders, there might be performance considerations. The cryptographic computations involved in MPC can introduce a slight delay or latency compared to signing with a single local key. Usually minor, but potentially noticeable for high-frequency stuff.
Okay.
And finally, if you're using a solution that involves a third-party provider holding a share or managing the system, there's a degree of reliance on that technology provider. Concerns about vendor lock-in or the long-term viability and support of that provider are valid considerations.
Right, so it's about weighing that enhanced security against potential complexity, costs, and dependencies.
Okay. Now, your sources also talked about applications beyond just holding crypto, didn't they?
Oh, absolutely. The flexibility of MPC opens up a lot of doors. Obviously, enhanced security for crypto management is the main one we've discussed, protecting investors and custodians.
Right.
But it's also becoming crucial for seamless management of institutional digital assets. Banks, hedge funds, they need robust multi-party controls, and MPC provides that. It's moving beyond just crypto. It's becoming about a new way to handle digital value securely with distributed trust.
Yes, their compliance and security needs better. Definitely. Then there's potential for secure off-chain transactions, facilitating faster, cheaper payments for certain applications by settling things using MPC without hitting the main blockchain for every step.
Interesting.
The idea of collaborative control in multi-device environments is also key, ensuring you can access things even if one of your devices is lost or unavailable.
So my phone, my watch, my computer could all play a part securely.
Potentially, yeah.
Yeah.
We're also seeing uses in revolutionizing digital auctions, making bidding for high-value items or NFTs more secure and transparent.
How so?
By ensuring bids are committed securely without revealing them prematurely, for example, or enabling multi-party escrow. It also, as we mentioned, provides simplified recovery for sharded keys, reducing that risk of permanent loss. Its enhanced protocol flexibility means MPC systems can often be adapted to work with different blockchains. And it offers scalable security for dApps, decentralized applications, aligning really well with their distributed nature.
It feels like a natural fit for that whole Web3 space.
It really does. It can also lead to improved governance for DAOs and other online communities, enabling secure voting and treasury management with multi-sig requirements built in.
Democratic control, but secured mathematically.
Exactly. And ultimately, all this contributes to stronger consumer confidence. Giving users more customizable and robust security options builds trust in the digital asset ecosystem overall.
It's a much wider impact than just wallets then. Okay,
Yeah.
let's get specific. The sources mentioned Lit Protocol, Web3 Off, Fireblocks. How are they actually doing this? What are their approaches?
Right, they showcase the diversity here. Let's start with Lit Protocol. The Oregon blockchain piece described them building a decentralized key management network.
Decentralized, okay?
Yeah, a key concept for them is distributed key generation, or DKG. This is where the network nodes collaboratively create a private key and immediately split it into shares without any single node ever holding the complete key, even for a moment.
So the key is born distributed.
Exactly. They also have something called programmable key pairs, PKPs. Think of these as distributed keys that are controlled by logic, like a smart contract, or even an NFT owner's rules.
Programmable keys.
Interesting.
Yeah, and they have lit actions. basically JavaScript code, that can run across their network nodes and interact with these PKPs to perform actions based on certain conditions, like making conditional payments or using Web 2 accounts to onboard users into Web 3 securely. It's about adding programmability to the key management layer.
So Lit is really focused on that decentralized network infrastructure and making keys programmable for developers.
That seems to be a major focus, yeah. Eliminating single points of failure in key management and enabling new kinds of decentralized apps. They also use threshold secret schemes, or TSS, which is closely related to MPC, for things like decentralized encryption.
Okay. What about Web3 auth? Their approach sounded different.
It is. The Web3 Auth article really emphasized their configurable MPC platforms. Their whole angle seems to be giving users choices to tailor the MPC setup to their specific needs.
Configurable how? They outline different models, like a storage-only MPC, where shares are stored using MPC techniques. But the actual signing happens locally on one device, which they point out still has a single point of failure during signing.
Ah, okay, so MPC for storage, not necessarily signing.
Right. Then there's server-only MPC, where secure servers handle the shares and the signing. Robust, but you're trusting the provider more, less self-custody. Then user-server MPC, which tries to split the difference, putting some shares on user devices, some with the server provider, a balance of control but potentially complex.
Right.
And finally, their ideal is configurable MPC, letting users mix and match storage, signing protocols, share distribution, basically maximum flexibility, but you need to understand what you're doing to set it up right.
So Web3 Auth is about offering a spectrum of MPC options, from simpler setups to highly customizable ones.
Exactly. One size doesn't fit all seems to be their message. Tailor it to your use case and risk tolerance.
Got it. And Fireblocks, they were mentioned frequently, especially in institutional contexts.
Yeah, Fireblocks is a major player, particularly in the institutional space. Their materials focus heavily on using MPC specifically for private key security to eliminate that single point of compromise.
Their core focus.
Right. They tout their proprietary algorithm, MPC-CMP, highlighting its speed. They claim one-round signing, which is very fast for MPC, and how it integrates with cold storage.
Speed is important for institutions trading frequently.
Absolutely. They also emphasize their key refresh mechanism, where the shares are periodically changed without changing the underlying key, adding another security layer against potential share leakage over time.
So Fireblocks, speed, institutional-grade security, and features like key refresh.
That's a good summary of their positioning. They present MPC as essential infrastructure for securely managing digital assets at scale, often as part of a bigger security picture.
Fascinating to see these different strategies. So looking out now, what's the future hold for MPC and wallets? Where's this all heading?
Well, the consensus seems to be that MPC isn't just a niche thing anymore. It's becoming, or has become, a kind of foundational technology for digital asset security. We're seeing major financial institutions adopting it.
So moving towards standard practice.
It seems that way. And as Fireblocks mentioned, it's often not just MPC, but MPC as a crucial layer within a broader security strategy.
And how does it connect with other emerging tech, like that account abstraction thing?
Ah, yeah, that's a really exciting intersection.
Yeah.
The Future Wallet piece talked about this. Account abstraction, AA, basically aims to make crypto wallets smarter and more user-friendly by making user accounts behave more like smart contracts.
Okay.
When you combine AA with MPC, you get something really powerful. MPC handles the secure, distributed management of the underlying key.
Right, the foundation.
And then AA running on top can add layers of programmability and user-friendly features. Think things like setting spending limits, automating certain transactions, enabling social recovery where friends could help you regain access.
Ah, so MPC secures the who can sign, and AA defines the what, when, and how they can sign.
That's a great way to put it. MPC provides the shared security for the key itself, while the smart contract nature of AA brings extensibility, custom rules, and a potentially much smoother user experience.
So could this combination mean we eventually move away from needing to obsessively guard seed phrases and private keys?
That's the hope, or at least one strong possibility. The synergy between MPC and AA could lead to much more intuitive, forgiving, yet still highly secure ways to manage our digital assets and identities online, making the whole experience less scary and complex.
Wow. This has been incredibly illuminating, a real deep dive. It feels like MPC is genuinely changing the game for digital security.
It really is a fundamental shift.
Yeah, the key takeaway for me is just that move away from the single point of failure. Instead of one key, you have these distributed shares managed collaboratively through math, It's not just more secure, it feels more flexible, opening up all these possibilities we talked about for institutions, for DAOs, for potentially our whole digital identity.
Absolutely. It really changes the paradigm.
So maybe the final thought for listeners is, as this stuff, MPC and AA, gets more mature, how does that change how we even think about owning things digitally? Could managing keys become, well, invisible, replaced by something smarter, safer, powered by MPC?
And what other doors does this open? Beyond wallets, where else could this kind of distributed computational trust take us? It's a fascinating space to watch.
Definitely something to chew on. We've only really skimmed the surface today, haven't we? This field is moving so fast.
It really is.
So we definitely encourage everyone listening to explore more. Check out the resources in the show notes: SLID Protocol, Web3 Auth, Fireblocks, those guides if something specific caught your ear. Keep learning.
Yeah, stay curious.
Thanks for joining us for this deep dive.